issues. My email is all full with all your queries. Just keep looking, because we have reported if somebody is having issue with DFMA and all. So the speaker will resolve the issue, or he will explain why the link is not working. So just wait. Everything will be resolved. Don't worry. Okay. I hope you cannot speak, but you can listen to me. Dharminder, can you confirm they can listen to me?
Yes, sir. Everyone can listen you.
Okay, guys, can you check YouTube video, YouTube live? Everything is working fine. Can they even comment, Dharminder, at this stage?
Yes, sir.
Can they message on the chat? Yeah, I can see they can message. Okay. Yeah, they can message on the chat, no? I'm just asking you, Dharminder.
Yes, sir. Yes, sir. They can message.
Okay, fine. So you can set the protocol, Dharminder, that if they have any question or something, they can directly write it. Guys, don't need to write yes sir, audible. You are not kids, okay? I understood. Everyone is listening, so it's okay, fine. मेरे बच्चे का क्लास होता है 9 बजे सुबह ना, एंड वहां पे एक बच्चा यस सर बोलता है, सब यस 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 सर बोलते हैं, एंड इट्स सो फनी. बट एनीवे, लेट्स नॉट गेट इनटू दैट. I understand I'm audible, so let's keep it smooth. And Dharminder, what is the protocol for asking question? Have you clarified them?
They can interact by chat medium.
Chat medium.
Yes.
Okay, fine. So in case somebody has to ask a audible question, we can see if we can allow one or two guys, depending upon the severity of the question that he
Okay.
not able to explain, we can allow him to speak also. That's
In this case, they have to raise their hand for asking.
Sure. We'll see how the session goes, what's the time limit and everything. So we'll see how. So ANSYS want engagement every 30 minutes. What I saw that from the yesterday YouTube testing thing. Am I right?
Yes, sir.
Yeah, it's fine. So everyone, Dharmendra will be your point of contact. I hope you don't need to call him because everything will be resolved here in the chat messages. So yeah, looking forward to the session. Don't worry if your computer is not working now and things like that. You will have time. You will get some homework to do in the evening. So yeah, we'll see. So in general, if you have any comment, how we can improve further, though I know I'm not able to, or my team is not able to answer your queries very fast, but you can write your suggestion in the chat box. If you think you are under some problem, or if we can do something better, you can mention it in the chat messages, and we'll take a look directly into that. Fine, have a good day, and I will get back to you at 9. Bye. Yeah, guys, I think one of the link on that dossier for Moldex 3D was not working, but now it has started working. You can check. I'm also sending that link here. You can open it here, but Sorry, this is not right. Sorry, this is not right. Mhm. I want to delete. Yeah, guys, I think one of the. Dharminder, can you delete my message also? Like, I don't know if you can do that. The link is different. Now it has started working.
Okay, I can send it to everyone.
No. You need to delete this. There's a problem. That link that I sent is not right. Yeah, but
I think there is no option for deleting.
okay. Sorry, let them enjoy. Okay. Guys, don't open this link. This is something else. Can you delete my message also? I can send it to everyone.
Hey, good morning. Hello. Side this side.
Hello.
Hi.
Uh,
Who's speaking, please? This is Said here. Yogesh, can you ask Balaji to look at that FTP link?
Dharminder, can you make one of the presenter also, like so that I can communicate with speaker? Hello, Mr. Syed, welcome.
Good morning. Yeah, thank you.
Yeah, good morning.
Room, sir, I make the presenter.
Side here. Yeah. This
Yeah,
window.
Mr. Syed will be the presenter and make me also as a presenter so that we can communicate in case of issue. You also become a presenter so that you can communicate.
Yogesh, can you ask Balaji to look at that FTP link? I'm seeing, guys, I'm seeing a repetition of what I've told my colleague. Sir, I make the presenter. Yeah.
Hello, good morning, everyone.
Hey, good morning.
First of all, I would like to welcome all students to this online internship carnival organized by IIT Ropar DST iHub Awadh. Now we have our first presenter, Mr. Said, with us, who is a product design cost analyst with 19 years of experience. He facilitates consultancy and workshops on new product initiatives. So it is very nice to have him with such a lot of experience. It is very valuable for our students. You get a chance to interact with such a great personality. So I would like to hand over our students to you, sir.
Thank you, Varendra. I'm still not able to share my screen.
Okay, Mr. Dheeraj, Mr. Dharmendra, can you please look into it? Make him presenter.
And Varinder, another request is I have two of my colleagues whom we did the trial run last evening.
Yes, sir.
Yogesh and thing. They have their video on. If you can identify them and also make a co-host just in case I need help through the session.
Okay, sir, we will do that.
Because as you know, we're all working from home. They're in their respective hometowns. And I have two systems here that are running parallel, but I would need help in case there's some anomaly with the setup.
Okay, sir, we will do that.
One is Mr. Yogesh and another one is?
Balaji, he's already not joined yet. Yesterday, when we were doing this thing, we had the opportunity to click on share system audio. I'm not getting it now. Yesterday, when we were doing this trial run, are you able to see my screen?
Yes, sir. It's visible,
Yes,
sir.
sir. Yes, sir.
Okay, I'm looking for that option where maybe I'll stop sharing into one more time. Sorry for where. When I say share screen, yeah, okay, got it. Thank you. I got it. You can tell me when to start and I'll be good to go. I'm good to go now. If you're ready, you want me to wait, you tell me, Varinder, and I will get started accordingly. Yogesh, can you speak and we just do a quick check?
Yeah, let's get started, sir. Good morning, ladies and gentlemen. I'm here to set this.
So we'll wait for Varinder to tell us whether we can get started.
Yeah, okay, sir. You can wait, not an issue.
Varinder, can I get started or do we wait for some more participants to join?
So we can start.
Okay, great.
Please go ahead.
Yeah. Good morning, ladies and gentlemen. I'm here to set the stage for the next 3 days training program. First of all, I welcome you all to the training program. I'm Yogesh, along with my colleague, Mr. Balaji, and the presenter of our 3-day training program, Mr. Syed Mubashir Ali. It's nice to see so many participants joining the session. Thanks for spending your time with us, and thanks for joining. A small brief about our presenter, Mr. Syed Mubashir Ali. He is a DFMA consultant for the past 20 years, and he's the trainer and have trained around 9,000 plus participants throughout his career. He has helped Fortune 100 plus companies to save millions of dollars in their product design. With this, I hand over to my Mr. Balaji. Mr. Balaji, over to you, gentlemen.
Thank you, Yogesh. Ladies and gentlemen, Balaji from this side. We have few house rules for next 3 days. Please have some way to make notes. Post the doubt question in chat box. Yogesh and we will respond at the end of our session. Ladies and gentlemen, I have a secret. Can I tell the secret? If you understand my question, please type S in chat box. The secret is, over next 3 days, Mr. Syed will share some bits of information related to DFMA methodology. These bits of information will come as an exit questionnaire which will be shared at the end of a session. So I request you to please attend this session, then only you can answer fully in exit questionnaire. In case we miss being together till end of session, please write to techsupport@dispert.com, support@dispert.com. Thank you. Over to Mr. Syed.
Thank you, Balaji, and thanks, Yogesh. And first of all, kudos to IIT Rupa team, Dr. Dheeraj, who gave us this opportunity, and the rest of the team who have met and who are here today to help us put this together. Over the next 2 hours for today, I have this agenda that I've laid out. I understand that you have been given an agenda, that it has just been changed towards the last minute. Just that to make this sessions much more useful and compact and probably deployable, that at the end of the 2-3 day event, you can actually start using this tool in your own projects and whatever exercises that have been given to you, student community. So without, if you've understood this overview agenda, I like to break up this whole activity into how I'm going to present it and what are my 2 topics. So basically, I'm not sure if all of you can see my video screen. If all of you can see my video screen, can you give me a shout out by saying yes in the chat box? Awesome. I know not very good looking, but what the objective of keeping my video on for so long was to show you this, ladies and gentlemen. I'm not sure if you can see this handbook in my hand. This is the Product Design and Manufacture 3rd edition book, whose cover page I've also put on the screen here. So this actually is a tool that has been around for about 4 decades now. It has been used by some of the most prominent automotive and aerospace industries. And the data that is available in this tool is manufacturing processes, manufacturing methods with the best from the industry practices, time studies, extensive academic research that is available as a part of the this package, and what this package is able to do. I want to let you guys know that just sit back and relax for the next 2 hours, listening and probably taking notes of what you think comes out interestingly. Because what I am going to do is I'm not going to make you to use the software today. We have time through the day to help you to get the software installation done. We have a lot of training PDF and videos that you can use to actually learn the tool. So this next 2 hours is to give you a gist of this tool using an example. So can I go ahead and do that? If you agree, say yes on the chat box. We are going to keep interacting like this because, ladies and gentlemen, I don't see you. So the chat box is the only way of your feedback to me, which is going to be impressive. Thank you so much. So I'm going to present two topics. One is called the design for assembly technique, which is used for doing design review. What is the benefit of this is normally you can never tell a mother she has an ugly baby, can you? It's the same with design fraternity. When you have a product that is designed and you tell the designer in his or her face, hey, this seems to have a shortcoming, it's usually a little hard to understand or assimilate after all the hard work that is put in there. What this technique DFA can help you to do is get a value of your product design idea measured in terms of time and cost. It also allows you to do different what if scenarios. For example, I have something and I wanted to put 4 screws. Should I say, why don't I insert at one end and put 2 screws? It is a good idea, but I'm not sure how it translates in terms of efficiency. I do not know how it translates in terms of cost reduction or time reduction or assembly simplicity. This kind of what if scenarios can be done for any new iterations and ideas using this technique called the design for assembly. So basically, this is a design review methodology. The other thing is I have a product and I've got parts of my product, right? So what part is good to manufacture this component? And if I have different ideas of material and processes for this component, which of them is giving what kind of outputs in terms of the cost to manufacture it, the difficulties of manufacturing, and so on and so forth. So for this, we will use this methodology, the design for manufacture, concurrent costing, to help us to do part level cost estimation. And these are the 2 modules in our tool that we're going to look at. Okay, so how do I intend to do that? And the benefit of all of these 2 tools is you can do a very intense, depending on your interest, your product review without you having to look out for manufacturing experts to help you with this assessment. Understand? So you have an unbiased way of getting feedback of your own design intent using the best of methodologies that have been documented as a part of a system. Now, this methodology, which is in this handbook, is in the form of a computing tool, which is what we're going to show you over the next 3 days. Would you like that? If you do, say yes on the chat box. I hope it's others also who are saying yes, because I can see only few names which I see repetitively. It'll be nice to see everybody participating. Thank you so much. So here's what I'm going to do, and please do have a good look at this tool, this assembly. I think a sample of this assembly video is also being given to you. So for our session of understanding of these 2 tools, I've taken a sample example of a subassembly. This subassembly is called a position sensing motor subassembly that is used in a very large printer. This printer prints things like flex banners and so on. So it is a large printer mechanism assembly. It actually is like a motor that moves back and forth on a guide rail. Okay, those guide rail that goes through these 2 holes. So what I've done here is I have got this bill of materials which is exploded here for the sake of our faster understanding, and a video that explains how this product should be assembled on the operator's table. So let me walk you through this video. Here goes. So what's coming up, the blue color is the base in which that yellow color press fitted bush is inserted. The motor is followed with the motor set screw, the motor screws. The red color element is an electronic sensor, which is held in position by a set screw. These yellow color standoffs allow the green color end plate sheet metal component to be placed on top and positioned by end plate screws. That is a plastic grommet which allows the wires to come through. The cover is slit in and the cover screws are going to be fastened. I hope this video was explanatory. If you've understood that video, give me a shout out by saying yes on the chat box. Thank you. So I have taken a few components from this product to bring your attention to understand our two modules to be validated today. So if you see from the video, these two components called the end plate and cover are sheet metal parts. And if you've looked at the video, these are the two components that form the enclosure of this particular product, right? Then if you see the remaining parts that I've highlighted here, except the base, this is not an important component for our conversation today. The rest of the components, which is the end plate screws, these two numbers, these standoffs, and these four cover screws, what are they doing is they're trying to hold these two end plate and cover together. So they're giving the functionality of having them fastened and held in position. You understand? And remember, this is what the product looks like upon assembly, right? Now, what I have as a question for you folks is, let us say today we are given a challenge. Our challenge is, guys, as a part of your project, please quantify this product design. Also, please find out if you can reduce the cost of this product. Please say if you can do some sort of a cost reduction or make this product more simpler to assemble. I have a question for you guys. How do you think you will go and quantify the functions of these different parts that I showed you in the product? Right? Every time we as designers, we always design a product to serve a particular function, right? Next thing is, how quickly do you think you can do it? And how reliably can be your results that you can actually say, hey, this is our design and here are my recommendations to make it simpler. And I can tell you that this is going to be the best benefit of it. How are we doing it today? When I say how are we doing it, I'm not referring to you as the academic fraternity. I'm looking at it as a question posed to the industry, right? Because these are actual genuine challenges that are happening. Also, imagine if I'm a part of that company when I'm making this product and my boss is giving me this target, which other department members should I go and talk to help me do this and get them involved, right? So thank you so much. I see some people who are giving me some feedback on the chat box, like efficiency, materials, minimize sheet metal cutting time. Very nice to see these things. But if you see what you are trying to give so many contributions of different ideas, how to do it in a methodical manner, how to get each of these method or ideas put into the basket and get a feedback of the impact of this idea from that basket, right? So I'm going to give you some overview of this approach to the DFA. Can I do that? So I'm going to show you a method called the Design for Assembly software. Of course, it's a methodology. I'm going to show you the software version of it. It is a world standard used by Fortune 1000 companies, even today, and to help them do the product design, product simplification and cost simplification. So let me take you into that module and let me know if you can see my screen, which says Design for DFA Product Simplification. Guys, I know I want the chat box feedback, but looks like some people are only doing chat box feedback. I want you to get your attention on the screen also. Wonderful. Okay, so here's what I have of that whole assembly that I've put up into the DFA tool. Rest assured, you're going to get a chance to look at this and work on this after this sessions are over, and we'll give you the guiding user manual and also videos to help you to do that. Okay, so now let's get some attention onto this screen. This is the Design for Assembly product simplification window. And the GUI is a very simple tool. Let me see if I can open up this. Yeah, it does. So what you're seeing here is a CAD imported version of this bill of materials. Imagine if I didn't show you that video, and if I had asked you, hey, what do you think is the best sequence to assemble this product? You would probably need some time to plan out what should be the assembly sequence, right? So right now we already know what the assembly sequence is from the video that we have shown to you. So let us go and show you the GUI. The graphic user interface of the design for assembly window has 3 parts. One on the left hand side is called the product structure. What does product structure mean? Okay, one more thing is, if you remember, Balaji talked about secrets. If you see me repeating anything twice or thrice, make sure you note it down. You're probably going to get it as a part of the questionnaire on the 3rd day. Okay, it is an objective type questionnaire, but you need to know the answers to give the thing right. So on the left hand side is this product structure. Now, what is product structure? It is the bill of materials in the sequence that you have to assemble this product. Can you see that this left hand side product structure has the same like steps that we had as we saw the video assembling the product together? And for each item on the product structure, the right hand side is called the design for assembly question and answers panel. So this Q&A panel is the heart of the DFA analysis. Ladies and gentlemen, you don't have to necessarily be an engineer to sort of use this tool. You're somebody who has a design idea, you're a product designer, you're an industrial designer, you have an idea of a product, you can use this tool, okay, even at a conceptual stage to get a rapid feedback of your design intent. So the third part of the window, is apart from the question and answers panel, is at the bottom here. If you're able to see my screen, results, which says the process time and the cost associated with it, and also gives you the time for the cost for the assembly and the item cost, which means each of the components in your design that you have put there. Okay, now I'm going to do a few steps of this assembly, and if you already have the document from us which says the motor assembly, which has a 3D image, you can use it. If you don't have it, don't worry. Try to recollect from the video and help me to answer these questions. And I'll tell you some of the things related to this window as we get ahead. Is that a fair one? Wonderful. So let me open insert a new analysis. This is how I probably do this exercise. I'll come back to this finished one, IIT requires, so I put it there. So I'm calling this as the motor assembly. I'm going to tell you what these steps mean. So when I start out an analysis, okay, whether you're going to make one prototype or you want to make a few hundreds or thousands of them, this is an important element called the life volume that you may want to enter in the in this window, because whatever costs you incur in terms of tools, special programming, consultancy time, and all other incidental costs will get amortized, averaged over this life volume that you want to manufacture. So just make sure that you know that you have to enter this, and it's important, gentlemen, and please take a note of this, because we're going to give you a singular exercise to be done. When you look at a product, okay, and they say, hey, do an exercise, DFA exercise for this product, you must challenge looking at that product. Hey, how many such products should be made if a company has to be successful? So depending on the magnitude of the product that you have at hand, you should be able to make some sort of an assessment. That assessment can be within your purview of your product. What I mean is, for example, I've got this marker pen in my hand. So if somebody in this marker pen, Faber-Castell, asked me to do an analysis, I would say, how many parts of this should I make? If this was a Montblanc pen, which is expensive, I look at it differently. So depending on the kind of a product you have at hand, you must make this kind of an assessment. Or if you're a part of the company, you should ask your sales team or your marketing team, hey, this new product that we have at hand, or this existing product that we're manufacturing, how much do we have as an intent to manufacture this? Okay. Second thing that is important for thing is to get your cost is, if you know what is your labor rate in your company or your institution, it is important that you get that numbers put in there. And the third element is, these are things, if you know, you key in. If you don't know, leave your database to as it is. Okay, you will be comparing your design to the world's best practices and getting a feedback when you make improvements, you're also going to compare those new improvements to the same best practices. So your ratio of your old and new improvements will be of interest to you. But I'm just showing this in the commonness of how this tool should be used. That these are some entries that is valid for understanding, and it is good that you key this information upfront. Okay, and this is my first entry that I've made. This is an overview. Through the next few days, if there is time permitting, I will show you how you can actually import a CAD model, how you can import bill of materials from your, if you've already done this product in a CAD model, that you can import the bill of materials also directly into the tool. But today, let us just do this as an overview, that we are doing it from a conceptual level where we have the design at hand. So can somebody tell me what was the first part that we had in our motor assembly? It was a base, right? If you remember from the video. So I've just put that element as base. What I want you to notice is I'm doing this approach like from a conceptual design stage in this exercise, but I'm going to show you later the actually completed analysis for in the sake of understanding this too. So thank you so much, everybody. Understood? Yes. Let's get back to my screen. So when you are given this first element, this question and answers panel is up here. So it's asking us, can you define some more details related to this component that you have? So first one it's asking is, can you describe what kind of an item it is? Is it a part or a subassembly, or is it a subassembly that you don't want to analyze? So in our case, this component is a part, so I will leave it there. Second thing it wants to know is, what is the weight profile of your part? So is it a component that is about 5 kilograms? Is it a heavier component, or it is a component which is more than 30 kilograms? I want you to notice, ladies and gentlemen, that as I keep clicking on these icons, depending on the selection, the question and answer panel changes. So our tool is called DFA product simplification because it knows what questions it should ask the designer based on the inputs that he gives. So if this input is different, it doesn't want one set of questions, it wants something else. So it keeps bringing up questions relevant to the previous questions so that we as designers can focus on our design rather than thinking which questions to answer, which questions are not important to answer, and so on and so forth. So right now, this base is a small part, which is less than 2.27 kilograms profile. I'll leave it at that. The next thing it wants to know is what type of envelope dimension is your product. So we have, as you can see, two types of envelope dimensions. One is a cuboidal shape, and one is this showing it as a cylindrical shape. Now, we can have a question like, for example, I have in my hand this mouse, which has got multiple complicated features. Okay, how do I just use simple reference of envelope dimension of cuboid or cylinder? So the Boothroyd method says no matter how complicated your geometry, okay, what we need to know in order to do a good DFA analysis, what's the maximum X, Y, and Z dimensions that your product is occupying? Why do we need that? Because these envelope dimensions are the way how the operator would interact with the product. So these envelope dimensions determine how the part is stored, manipulated, and how the operator interacts with the part when he brings and uses it in the part of the assembly. So when you have your component, no matter how complicated features you have, just make sure that you take the XYZ envelope dimensions of that particular part, right? Next thing, which is critical, ladies and gentlemen, is to understand and give an answer to this question, which is, hey, does your component have a function? Now, if it has a function, you must be able to say what type of function do you think it has. So there are three major categories. One is called fastener, second is called connector, and third, we as a user can tell whether the component has a function. In this case, this first component is a base part, so I think it has a function, and I want to do this. Excuse me. The function that it has is if you mark this icon saying that the item has a function, then it brings up this question called minimum part criteria. If you select any of the previous icons, you see that minimum part criteria question is not up for the user to answer. So in this selection, it says if you think the component has a function, can you tell us under these different categories which is the most closely describing function of your component? Now, ladies and gentlemen, in the interest of if you're seeing my screen, can you tell me? Yeah, wonderful. So this is a base part, the compass chassis or the frame on which the product is going to be built. So I'm going to say base part is option for this particular component. We'll talk about these other options as we go through the presentation. Next thing it wants to know is what's the symmetry of your part. I'd like you to know that if the part has lesser symmetry, then that product takes a little more time for the operator to assemble. If it is more and more symmetric, please notice the process time on the bottom. The process time becomes lesser. So, you know, VDI, the Boothroyd Doers method has estimated from multiple case studies and come up with a number. It says the ideal time for picking and placing a component in assembly should be 2.93 seconds. Now, you may ask why 2.93, why not 3 seconds? Why is it like a Usain Bolt, 100-meter dash record? But that's the research that has gone behind this, and this is the ideal time for picking and placing a component in assembly. Okay, so right now this is the component which is a base part which has no axis symmetry. So I'm going to leave this. We'll talk about these details as we go a little more further in the next 4 entries. The other thing it wants to know is how does the operator pick and handle the part when he brings it to the point of assembly? No, yes, Manash, this is not the process time to make the part. Good question. So in the interest of Manoj Ram Thakur asking me this question, I want you to visualize, ladies and gentlemen. Imagine that the parts are already available on the desk or the assembly line for the operator or the assembly line technician to put the component into these components into a product. This is what the design for assembly does. Each of these components, how you want to manufacture, we are going to investigate using the design for manufacture tool. That is where you will do part costing. Thank you so much for asking that question, Mananj. Appreciate it. Okay, so I hope you can keep coming back and thinking about this, that we are looking at the parts which are already available, we're picking it and going to use it for assembly. That's what this tool is. So the next question, as you can see here, is what is the handling requirements associated with this tool, or with this part to be assembled? So as you can see, there are different options that are laid out for handling requirements. Right now, for this base part, one hand is sufficient to handle, so I will leave it. If you have a doubt what these other questions mean, you can go and pick on this on context help, and it will bring up. Are you able to see my screen? It will bring up these kind of user-friendly different assembly explanations that will bring about what does the meaning of those options mean. Okay. This on context help is available right there. Let me close this first. On this this blue color icon with a question mark is the on context help, and that is what will guide you. When you click on a menu and you click on this on context help, you'll get what that relevant menu or icon explanation is. So there are two elements to answer here. One is the handling requirements. The other is called the handling difficulties. So if you visualize that the component has a difficulty, click on it, understand it. Okay, that's what nest or tangle means, like springs and open-ended components. If you don't see a difficulty, don't click it, because if you go to click on a difficulty, the difficulty is going to add a penalty time. The penalty time is going to multiply with your labor rate cost. The labor rate cost along with the efficiency is going to get built up in your process cost. Okay, so as design for assembly experts, which you're going to become as you start using the tool, you will not be very benevolent, but you look and criticize each of these difficulties and try to solve them as you make better and better and better products. Okay, so there are two attributes on how the assembly is done. One is the issues related with handling the part. If you see my screen, the other is how does the operator secure the part. So one is bringing the component to assembly. One is actually securing the component into assembly. So in securing, there are, as you can see, some 6 icons here. So there are different explanations of how this component has to be done. In this case, this is the first component. So added and not secured seems to be relevant for this part. And if you foresee any difficulties, you can also click on this. But right now, this is a single part. You don't have to do it. If you want to write, you can take notes. This is a conceptual design activity. If you want, you can bring in and load in files that can, if it's an image or a sketch, you can also load the file right here. Okay. So let me go and add the next part. What is the next part in our design? Yes, Soumik, the symmetry of this part. If you look at this component, if you look at it from this, if you look at this component, this is a base part, right? Actually, it is quite symmetric from, if you look at it from one point of view. But from an operator's perspective, if you look at these holes, you would like to bring it and assemble it in one way. Then only he'll be able to pick and place. There's also another hole here for the set screw, right? So the symmetry of this part is he will pick the component and he'll place it in one orientation to which is in his vision, so that he can construct the rest of the parts inside that design. So the symmetry for this part is that it is got no axis symmetry. So no axis means one way orientation, one way insertion only. Does that make sense, Soumik? If it was something like a ball bearing, it would have been a two-axis symmetry. If it was something like a screw, it would be a one-axis symmetry. If it's like a hollow cylinder, it would be a two-axis symmetry, so on and so forth. I will answer some questions as we go ahead. But thank you so much for asking the question. It's nice to see a lively interaction here. So what's the second part that we have to add? Everybody is very fast with the base part. Now let us see who knows, who recollects what the second part. It's not the motor. Bush. Yes, thank you, Ashwin. It's the bush. Correct. The bushing is the part. So let's go and add a part. As you can see, gentlemen, right now, I'm not, sorry, I'm right now doing this conceptually, but I can also add singular parts if I want. So right now, this is a bushing. How many, can you describe what is the item? Is it a part or a sub-assembly or a sub-assembly not analyzed? What do you think? Best, correct. Item weight, will it be less than 2.27 kilograms? Right. And for the envelope dimensions, what do you think would best describe it? A cuboid or a cylinder? So sometimes you may have parts that are closely cuboidal in shape when you place it on the ground. Something closely resembling a cylinder placing on the ground. You can choose. There is no one way of solving these questions. There is no perfect product in the world. Okay. So one man's approach could be slightly different from somebody else's. That's okay. Right. Now, correct. Repeat count. Thank you so much for pointing out. I was hoping somebody would do it, but again, it's my colleague who's done that. If you see there, in this bushing, how many bushes do we have? We have 2 bushes, so we would say 2. Specific reason, Yogesh, can you catch that question which went up from somebody related to specific reason behind selecting product preference? I tell you that, Kunal, it will help you to build the hierarchy of your different levels. I will like do 2 more components. I will show you the importance of that. Okay, just hang on. Thank you so much for asking that, Kunal. So the cylindrical shape, and if you know the values of that, you can actually key in the dimensions. I forgot to do it for the previous element, but nevertheless. Now look at the envelope dimensions. Tell me, what do you think is the function? Is it a fastener? Is it a connector? Or do you think the component has some function? In my case, in just in the interest of time, this is not a fastener. This is a component that has a function. Basically, a bushing is used. Let me. Okay. You need to listen to me carefully now. Now, this is the bill of materials. Are you able to see? This bushing is inserted into the circular hole. Okay. And if you imagine the fully assembled product, which I showed you in the video towards the last, the guide rail will go through this hole, pass through the bushing, and this whole mechanism goes up and down on these 2 guide rails. This bushing is made of brass. This base is made of aluminum. The reason why the bushing is made of brass is because it's got some good frictional properties. Right, that is why in the initial design they've had this bushing that is press fitted into this product. Okay, now with that in mind, let us go and answer the questions for this bushing. So the bushing has a function. Now let's answer them with yes about related to wear resistance. Is all right. So let me go and answer these questions one by one in a methodical way. We'll come back to this, Debashish, Yogesh, and Balaji. Please follow these questions. We'll cut paste and reply to them as we go ahead. It is in dollar because this is the out-of-box solution. You can customize it to different currency as a part of the reporting. Okay, Debashish, there is here. Can you see this? Change currency. So we'll come back to that. Now, is it a base part, this bushing? No. Does it move relative to other items? Absolutely not, because once you insert the press fit into the part, it will stay in position. It's not going to move relative to other parts. Is the bushing required to be made of a different material? If you think about it, the base was made of aluminium, the bushing is made of brass. So the reason why it is made of brass, so that it has frictional properties that can be utilized for wear and tear. Let's go back for a moment and look at this 3D model. Okay. Okay, look at this 3D model. Okay, now let me ask you a question. I have been given a task to do product simplification. I know there are so many advent of new materials that are available. So right now this is made of aluminum and this is made of brass. But is that the reason why it should be there in order to exist? Can this product not work if I do the following? Listen to me carefully. If I machine the ID of this aluminum as the ID internal diameter of this aluminum base as the internal diameter of the brass, won't the function be still satisfied? Can this motor still work, this assembly? The answer is a yes. So this, in order to achieve the functionality of this product, this is not a critical component that should be there. In that sense, even though it is made of a different material, it is still not required, but not satisfactory or not compulsory for the function to work. So when I have such components, many a times we build a product which has such a secondary or tertiary requirement, but not necessarily aligned to the function of the product. If you want to be a good DFMA person, you're going to critically give these kind of a scoring of identifying the parts which are critical for work and not critical for the function. Okay. So that way, ladies and gentlemen, this minimum part criteria will says no fundamental reason exists for that particular bushing. What I'm saying is, even though the part component is here in my design, when I'm doing my review, I'm identifying it as a component that not necessarily required for a fundamental functioning of this particular product. Now you come to the symmetry of this. I'll come to the fourth option. Hang on, I'll come to it. Thank you so much for asking. Look at the symmetry of the part. Now you tell me, this is a hollow bushing, right? Like a hollow bushing like this. I'm not sure if you can see there's a cap of my bottle. So I can insert the bushing like this. I can also insert it this way. So while inserting it this way, I can also rotate it 360 degrees and it will still find its way to insert, which means it is a component which has two axes of symmetry. Let me repeat. If this was, let us say like this cap, I can only insert one way, right? But when I'm inserting this cap, I can rotate it 360 degrees and I can insert it into its position. It will insert itself. If it was this kind of a component, I would have said it is a one-axis symmetry. But our bushing is a hollow cylinder, right? It can insert this way, it can insert this way. That is why we selected two axes. Am I clear? If you understood, say yes in the chat box. Awesome, guys. You're a wonderful set of folks here. I'm liking this. So now let's go and talk about the handling difficulties. Is it does it have any handling difficulties? It doesn't. So I'm going to leave it as one hand without grasping tool. Does it have any difficulties related to picking and placing it? No, it's a fairly good size component which the user can pick with his fingers and place. So they're not selecting this. Now coming to the securing method, in the interest of the learning process, let me say that the bushing is placed in that slot. Then I'm going to use a press tool to press it into position. Let us say this is what, push fitting. But right now it is not directly push fit. Let me say I want to add it and held down. Okay, then I'll use a press tool. So the reason why I'm doing this is I want to show you the operations library. That is why I'm doing this. Okay, so I've answered this question. Let us also say that the bushing does not have has an alignment problem. If it has an alignment problem, then I will say it is not self-locating. So these selections as you make, as you can see, is adding some process time to this. Process cost is the same. Yeah, the process cost is determined by the labor rate. Ashirbad Sahuji will shoot that question out as a note. We'll get you some answers and send it to the rest of the crowd. The process cost can be determined when we do a project by figuring out what is your local labor rate. That is an activity you can do when you're doing localization. So we'll talk about it in a minute. Maybe towards the end of the session, or maybe as we do the hands-on exercises. Okay. So I've added the bushing. Now, as I said, in the interest of this learning, I want to show you how the operations work, and I'm going to give a press fitting operation for this bush. So here is my ability to add operations. I can insert an operation here. And what comes up is, are you able to see my operations library screen? Yeah. There are several different operations that are normally used as a part of assembly methods. So I'm going to select this option called secure items that are already acquired, which means the bushing is already acquired, and I want to do a push fitting operation here. So I'm going to select the push fitting and say insert. So from this library of operations, this operation now has been brought into my product structure chart. And in this push fitting operation, I'm just going to say I have two push fitting operations to do, and I can give these dimensions if I have, and if there are some other problems that I am seeing, and based on this, it will automatically get captured as a part of this activity. So let me go and now add, in the interest of time, the next part. What is my next part that I have? If you remember the right now, you answer the question for me, please. Is the motor a part, subassembly, or a subassembly? It's not standoff. Motor is a subassembly. So when I say subassembly, you see the icon is like this. Somebody answered this question before. So, which means in your product, you have a subassembly, and if you want, you can go and build the parts inside your subassembly also. Okay, but right now, as I told you, we are going to treat this motor as a bought out component, something that you have purchased from the off the shelf and utilizing it as a part of your assembly. If that is the case, you can say it is a sub-assembly, but I'm not going to analyze the parts inside the assembly. So I will say it is a sub-assembly, not analyzed. Understood? Which means you don't have to necessarily treat and analyze the parts inside this motor. So with that question answered, what do you think is the weight profile of the part? It is less than 2.27. You can know that from us. You can give the envelope dimensions of this component. It has got a square base. I don't know the dimensions right now, but I'm just going to put this anyway. Okay. And now, if you look at this item function, let's go and answer this. Is it a component which has a function? Yes or no? Yes, it does. In that, now this is a critical part, and there are some questions and secrets that are going to come out here. I hope you're all paying attention. Now, let's go and answer the minimum part criteria. Now, the minimum part criteria is, it is not a base part. Does the parts of the motor move relative to the other parts? Hello? Okay. Let me also answer another question, because the spindle of the motor, even though you have bought this component as a off-the-shelf component, the parts inside the motor, which is the spindle, has to rotate, and that rotation is required for this product to work. Hence, we will say moving relative to other items is the critical minimum part criteria for this motor. Understood? If you understood, say OK on the chat box. Okay, now listen to me carefully, and I'm going to show you another set of slides now. So repeat, sir. Okay. In the interest of one person who said repeat, I'm going to do this one more time. If you look at the shaft of the motor, even though this motor is a bought out component, the shaft has to rotate, And this rotation is critical for the overall subassembly to work. So that's why we have selected move relative to all other items. So if I selected a motor, mostly this icon or this option, move relative to other items, serves the minimum part criteria. So the next 4-5 minutes, what I'm going to do is I'm going to give you some relevance of the minimum part criteria. If you understand this well, many of the things of DFA is sort of understood. But looking at the motor, isn't the motor a subassembly of parts? Yes or no? And the motor has different materials inside. If you look at the shell of the motor, it's made of sheet metal. It's got magnets. It's got copper windings. It's got PVC insulation. It's got a stainless steel shaft. There are so many components. So actually, technically, if you look at it, this icon called must be made of different material. Even satisfies the minimum part criteria for the motor. Moves relative to other parts because of the spindle. Different composition of the motor because of the different materials. Both of this satisfies the minimum part criteria. Then the question is, sir, can I go select both of them? No, you have to select the more important aspect that it serves. Then that brings up the next question. What is the impact of minimum part criteria to this whole process? Do you have such a question? Let me repeat. What is the relevance of this minimum part criteria? Right? Yes, efficiency. So can I show you a quick overview of that efficiency and what the minimum part criteria means? If you want to, say yes on the chat box. If not, I get ahead in this presentation. Okay, thank you so much for that. Just give me a second. I have it in my desk. Let me see if I can drag it up. Okay, are you able to see this? Are you able to see the screen? Okay, now what does minimum part criteria relevance mean? So the Boothroyd method says to the user, based on the user's perception, why do you think the component is important for the product? This question is something as a user, your perception. So there are 4 different attributes to this. One, if it is a base part, like in this case, on which the components are assembled, then that is option number 1. Next option is it should be made of a different material, which means like in this case, this electrical insulator has a different set of screws. So this electrical insulation is required, then only this product can work. Something like this should be critical for success. For example, I'm not sure if you can see that I have this mouse. I have 2 sets of wires, which are copper, and each of them have a PVC or a protection coating on both of the wires. Do these require, do I need these 2 separate wires with this insulation for this product to work? Yes, I need a positive and a negative wire, then only this product can work. So something like this should be compelling, where the material has to be different. So electrical insulation, thermal insulation, these kind of attributes. Understood? If it doesn't satisfy this, the third thing is it should be probably a component that moves relative to other parts, either more than 360 degrees of revolution or a translatory motion like up and down, where translatory motion that is required for the product to function. Other plastic bushings used above the motor in the assembly used in, I didn't get your question, Avantika. You want to frame that one more time? I'm talking about yeah, this, see what I'm doing, Avantika, is I'm doing this demo as if I'm reviewing an existing old design. Okay, coming back for the newer ones, I'm going to show you as we make the improvisations. Okay, let me come back to that. And the 4th attribute in the minimum part criteria is, should the component be separate for assembly purpose? These are the 4 different criteria for which which classifies itself as the minimum part criteria. One is the component should be a base part. 2, it should be made of a different material. 3, it should be moving relative to other parts. 4, it is required for assembly. What I mean by required for assembly, let me give you an example. The cylinder head of your engine and the cylinder block are both made of the same aluminum alloy. But why the cylinder head is made separate is so that you can put the piston, connecting rod, gudgeon pin inside the cylinder. Otherwise, if you have it as a singular part, you'll never be able to put those components together. So something like this makes it as a criteria for assembly. So these 4 categories form the minimum part criteria question. If it doesn't satisfy this, then the remaining parts should be viewed as candidates for elimination, as we call it. Under this, as you already seen, one is the component for connect or fasteners, nuts, bolts, rivets, screws, washers. Second one is connectors, which is conduits, cables, wires, tubes, ropes. And the last one is redundant components. For example, there was a hole. To cover this hole, he's put a plate and put these 4 screws along with nuts and washers. Cannot find a way to make it simpler. Something is what here we have applied as a thinking for the bushing. Understood? You understood, say okay or understood or a yes in the chat box, please. Now, let's go back to this presentation for for a while. Now, you understood that the motor has 1 and 2, both options relevant for the motor, but we are taking the more important criteria for the motor. Now, the next question is, sir, what is the importance of minimum criteria? Where does it impact? See, when you select this icon or any of this, when this option, this gets reflected in what we call as the design for assembly index. See, a design for assembly index is a measure of comparing your design to the world's best practices that is a part of our system. Okay, and for the actual time that you have for assembly, for all of these steps that you're carrying out, and giving you an indication of how much it is compared to the world's best practices. Now, can this be 100%? No. But what is it that is a thumb rule for me to look at? Nothing like that. You making a comparison of your design as you build your product structure, you get a feedback. As you keep making improvements, you get different numbers. That improvement of the old and the new, which is using the world standard as comparison, is your reference of improvement. I will imply what I mean as I show you the overview in the next few 10 minutes, 4-5 minutes. So let's come back to the motor. I hope we understood the importance of the minimum part criteria. This is very critical for success of your design for assembly review, ladies and gentlemen. Okay. Next, if you look at it, the symmetry of the motor, actually the motor has a square-like base. So you could probably rotate it about 1 axis and insert, but maybe there's a challenge with the motor wire. I don't know. So if that is the case, I will say no axis, which is preferable. What would be considered a good enough index? There's no reference of a good enough index. For a commodity, let us say like a computer CPU, the BDI index would something like 3 to 5 or 7%. For a mechanical enclosure, it could be 10 to 15%. That doesn't matter. From that existing design review, when I make an improvisation by a few degrees, that is what is important for success. It's very first in itself. Very first in itself. Doesn't matter. You're comparing there's an empirical formula for DFA index. You have a software tool. Go look at it, and you can look at the DFA index by clicking on this. You'll get the answers for that. We will talk about it when we go ahead. But so there's an empirical formula that drives DFA index. We'll talk about it as we go through the presentation. But it's good that you're asking these questions, so you know where these elements are as a part of the your product design review. So shall I continue? Yes, you can do multiple comparisons. Yes. So for this motor, the more important criteria is called move relative to other items. And the motor I've selected as a 1-axis symmetry. I can use one hand to handle it. No handling difficulties, maybe requires careful handling. I'll select it. And the securing method for the motor is, I want to pick and place the motor. And then you saw the video, right? I'm going to take 2 screws to fasten it. Can you tell me which of these 6 icons will be apt for securing the motor? The securing process, which of the 6 should I say added and not secured? Should I say snap? Should I say threaded fastening? Pop riveting, huh? Okay. Add and gold down, correct. See, I'm answering the questions for the motor right now. The threaded fastening is actually of the motor screw that should follow after this, right? You get it? So for this motor, either it has to be added and not secure, or maybe added and held down. Why will it be held down? if the motor screw hole is not aligning with the hole at the base, I'll have to align and hold down till I pick the motor and fasten it. If you can see my video also alongside, I'm not sure if you can. That's when you'll use this option. Because adding and held down adds more process time than adding and not secured. Just know this. But if your actual component asks for this activity, you should go and select this option. So let's add it and held down, and let's do one last element on the motor screw before we get ahead. Okay. So the last component I want to add here after the motor would be the motor screws, right? How many such screws do we have in our design? Do you know? We have 2 screws, and it's a small item. It is a cylindrical item, maybe about 8 mm diameter, 15 mm diameter. So what is the function that this motor screw has? Fastening. So when I select fastening, see the minimum part criteria question is gone. And what do you think is the symmetry of the motor screws? One axis, because if you see a motor screw, it has a head and it has got the spindle where the thread is there. So I cannot put the motor screw upside down, but whichever axis I'm inserting, any point 360 degrees I can engage it. That is why it is a one axis symmetry. Okay. So I can say one hand is enough for grasping it, but maybe it is requires maybe slips from the finger or something like that is a handling difficulty. And the securing method for the motor screw would be, I would be able to select threaded fastening. See, the product is so nicely designed. Depending on previous option that you select, it will bring up the characteristics or subsequent questions. Like when I selected threaded fastening, it's bringing up the operation characteristics for threaded fastening. Okay. Yeah, it doesn't matter whether it's clockwise or anti-clockwise rotation. The item is you have to do the act of fastening anyway. And the act of fastening is captured by the operation characteristics. So if it's a power tool with 5 revolutions, this is your time. If it is a nut screw, this is the time. You just look at the process time. If it's a ratchet, if it's an open end, where are these times coming from? These times are coming from a database that has been refined, documented from world's best practices, and available for you to pick and use it. So if it is a power screw with 5 revolutions, gentlemen, this is the time. What if it is 6 revolutions? What if it is 10 revolutions? You see, as designers, I'd like to take a moment to explain here. We do not solve this kind of function requirements and see the impact of this function requirements in terms of the time we have. So if you have a very fine thread, 20 revolutions, like say the wheel nuts of your car, it takes a lot of time to assemble it. Do we know how to capture that problem? This tool does that and quantifies this act. That's what it does. Okay, so let us leave it at that. So what I've done here so far, ladies and gentlemen, is I have captured these steps of our activity. The only difference here that you're seeing in this completed analysis is I have also added the image of the photo of the component here, and I have used the product structure to build this whole hierarchy of the components in my design. Okay. Now the next stage is when you have such a review done, such a key steps done, you can review this design. Are you able to see my screen? You can review the design like how industrial engineers would do. But more importantly, we have an interesting feature in our software called suggestions for redesign. The suggestions for redesign is a window that categorizes all of the entries that the user has. Yes, Anmol. What I'm saying is, Anmol, first thing is you build your product structure in the sequence that you want to carry out your review. Like in this case, I have done the assembly steps of this particular motor assembly. As a matter of fact, you can use this product for also doing. Right now, you see, I'm doing an assembly order sequence. For example, somebody could give you a challenge. Hey, I have a product which I in the field, like say maintenance of a car, the disassembly by the mechanic is different. So you can do a disassembly sequence also if you like using this tool. Right now, we have done an assembly sequence of this motor parts, this motor assembly part, which forms the full product after you put all of the parts together. what I'm going to use this tool for. I want to use the DFA tool to help me to find out where are the opportunities for improvement and more. So I can do that by looking at my product using this suggestions for redesign window. Yes, the hierarchy can be altered of the assembly. The cost will not vary unless you answer the questions differently. Order does not matter. Order is for us as a user to understand why we are doing this order. So the suggestions for redesign window, what it does is, based on the entries that you have put in as a user, it finds out opportunities for improvement under these 3 different categories. Let me bring your attention to the fasteners category, ladies and gentlemen. When I click on fasteners, can you see this? Now, the software does not know all of the design data. What the software knows, based on the inputs that you have given Shanmukh, it will, and the difficulties, handling difficulties, symmetry, insertion difficulties, insertion issues. Based on that, it groups up all of that in elements and gives a breakup under these elements, under these attributes. More importantly, it captures the time that you are going to be contributing because of all of those issues and summing them up under different headers. Okay. So let's stay here for a minute and look at only the fasteners. Now I'm looking at the category for redesign. I'm first bringing my focus on the fasteners. Okay. If you look at this fasteners, what do you see? Which is the highest time contributor? Can you tell me? Which is the highest time contributor? Cover. The cover screws is the highest contributor. Now, if I am a part of a design team that has been entrusted with the activity of doing product design review, I will take my attention to the large time contributors in my design and go challenge and find out what is it that they are doing. Is there an opportunity to increase and so on and so forth? Shall we do it for the cover screws now for a minute? Yes or no? Okay. So let me park this window here. Let me close this. Let me go and show you that this is the method that we have done. We had a situation previously. Our situation was we have a motor and I brought your attention to these parts. Now I'm showing you the method where I've done this in the DFA. Now, before I go back to this, let us look at this and ask, what are we doing in this few parts? Now that you have done a DFA review, let us focus our attention on these 4 parts. Just imagine that we've answered the questions for all of these parts also. Okay. What I showed you was a quick demo of the DFA tool. Now, if you look at this part, and you'll see that this end plate, one component, and this cover, the second component, is here. I've also put these 5 other parts, the end plate screw, cover screws. Let us start looking at the cover screws. What is the cover screws there for? The cover screws was there for holding the cover in position, correct? What is the cover there for? Well, this is working in a hazardous environment, so we need a cover to protect this product. Okay, is the cover the only component that is protecting? No, the cover is protecting from these 4 sides. The end plate is protecting from the top. So in order to do the act of cover protection, we have these 2 parts, cover and the end plate screws. So is the end plate held directly? No, it needs an end plate screw. Is the end plate screw directly held? No, it needs a standoff. So if you look at these 10 parts that I have grouped together, I mean, see, the DF analysis doesn't happen so easily, but just in the interest of the learning, I've grouped them up to show to you. And I've categorized them into 2 large categories. If I look at these different parts, for the act of protection, we have 2 sheet metal parts, the end plate from the top, the cover from the bottom on the sides. And in order to hold them together, I have end plate screw, cover screw, standoff. Totally, I have 10 parts to do what? To do the act of protection. Come on. This is what I've been able to identify. And in that, the cover screws is taking about 34 seconds. Now, yeah, we can reduce it. That's why we're going to use the DFA tool. What I'm showing you is the method to this madness of how to do this reduction. So, and remember, do you remember this image? This is what the product looks like when it is assembled, right? Now, ladies and gentlemen, I have some challenges for you. When you have a design review to do like this, what do? You will sit with your friends, brainstorm for ideas, create new ideas translate those ideas into sketches and CAD models, discuss the different aspects that you think would improvise. Most likely, all of this will be a quest that would lead to a new design, correct? This new design may be, like I've sketched it right here, but in an alternate like this. I've said, hey, look at these two parts. After assembly, they look like this. And I've done a hand sketch which looks like this. And my friend, my other team member, has made maybe a crude estimated 3D model of what it looks like upon assembly. Now, when you look at this, is it a possibility that we can explore? It definitely is. Now, when you have something like this, we're going to have another set of challenges that we're going to do, especially, gentlemen, I'm not looking at you as academic students alone. I'm looking at somebody like you who's going to go tomorrow into an industry and be a part of a design team, where you will be faced with this challenge that when you propose a new idea, your boss, your team member, yourself, I'm going to say, how am I going to quantify this idea? And if you're a part of an enterprise, how do I tell my manager? How do I tell my teacher, my faculty head? Give me the time and the tools and tackle and lab so that I can go and validate my new idea. Then who should I go look out for in order to help me do this validation? Many a times, millions of dollars are lost on the table because this ability is not there. I had a good idea, man, but you know what happened? No time, man. Project is too heavy. I forgot about it. 2 years later, I realized that we lost so much money doing that new revision. You'll see up to a number of stories like that in the industry. I want to come back to this next stage of this new idea that we are going to create, this new idea. But before that, let me conclude what I wanted to share in the DFA window. So when I looked at this component, which had the largest contributor, I challenged it. I did a design review with my team, and I came out that is the possibility that we can combine these two parts and make a singular part. And that singular part could look something like, something like this. Now, as I said earlier, this is not necessarily a CAD image. It could probably just be a sketch that I drew on a paper while having coffee. And but I have an idea now. What do I do about this is I can use the DFA tool and I can make a quick review of my old and proposed new idea. Just give me a second to generate the report. Sorry. Not able to see my. Yeah, here it is. So let me maximize this old and new design. So gentlemen, this is our old design and this is our proposed new design. We've not made a CAD model. We've just got an idea. Of that idea, I'm able to create a potential review. So let me just quickly look at some of these attributes. So the old design had about 36 different entries in the bill of material or the product structure. A potential new idea could just have 8. The old design takes about 261 plus seconds of assembly. Our potential new idea could have 75. Okay, I can look at different attributes around this particular product. Okay, and generate different reports around this. So let me come back and show you that this is my old and new ideas, and I can look at different other elements of the same product. That's a cost breakdown of my old design and my new design. This is the process time and the process cost associated with it. Now, what does this mean? I will just tell you in a minute. I want this as a paragraph, not as a stack bar. It's easier to. What I'm showing you is the latest version of the software. So you have access to this version of the tool. Are you able to see this graph? where I'm talking about the process profile and the assembly time. Let me just maximize it a little. Yeah. Now, if you look at this old design, ladies and gentlemen, look at this. The overall time for your assembly in your old design was about 260 seconds, of which the fasteners alone were contributing more than 155 plus seconds. Those components which the user through the minimum part criteria questions has answered as necessary, the necessary items are only contributing about less than 25 seconds. Can you see this? With our proposed idea of making a singular cover where you get rid of the standoff and the end plate screw and the cover screw, we have a potential to reduce the fasteners and get something like this, where the fasteners will take less than 30 seconds and the overall design time can be reduced by 75 seconds to 75 seconds. This rapid feedback of your design intent is what the DFA tool helps us to do. Let me just generate a couple of ideas for you and talk about those ideas in a minute in the interest of time. Now, do you remember this motor? And do you remember the motor's video? It had 2 screws. Let us say if you wanted to make it as a foolproof design, wherein in the base you make one chamfer here, okay, so that the chamfer also has the motor. Okay. So when you place the motor, there's only the chamfer that can mate with the chamfer of the base, so you can use one motor screw to insert it. Let us say if I have an idea like that, how do I validate it? I can make a copy of this. I will make a paste of the new design. I will rename it. I'll call it as IITPR Idea 01, in which I'm going to reduce these motor screws from 2 screws to 1 screw. Now you may ask, sir, how is that 1 screw going to look like? What is the engineering drawing going to look like? What exactly will be the details? You do that engineering part later. But when you have an idea like this, can I get a feedback for my potential new idea? That is what the DFMA software can help you to do. So I'm going to do a quick review of the old idea, new idea, and the IITPR idea, which I just now created last 1 minute. You see this? The old idea, the fasteners were taking about 61% or $2 cost. Fasteners in the new design is going to be 41% off, 0.4. In the IIT design, it's going to be about less than 33%. You can create in terms of time. You can create in terms of different currency. Like you can have a conversion value that somebody else asked me. The base value is designated with a dollar symbol in our software, because all the calculations are standard across that dollar value. But you can localize it by putting a different value, like I can say INR. I can put the conversion value here at 75, and I can get a repetition here, and the whole thing will be recalculated for this. Okay, I hope that helps you to answer somebody who asked that question earlier. Similarly, I can do different other cost breakdowns, and there are about 7 different types of reports that we can generate with this tool. What I showed you was cost. You can also do in terms of time and so on and so forth. Okay, so in the old design, it would take about 160 plus seconds. As you can see there, 159 of the total time of 260 seconds. With a potential new design, you can reduce it to nearly 30% of this. Now, I'm going to the next phase of my presentation. I think I may be a little running late on time. I think I'll push the case studies for tomorrow. Let me answer these questions that are up on the chat box. How can we select which design is reliable? Gaurav, there is no perfect design. You keep on improvising based on what you think is the best approach you can do with the skills that you have, with the team that you have, with the time and money and the project allocation that you have. That's how it works. If they were perfect products, Microsoft wouldn't be making so many versions of their operating systems. Car manufacturers wouldn't be making one version of cars, right? So have that approach. Is the time factor taken as a default by the factor? The time factor is coming from a database which has been standardized over the last 40 years. What is the minimum error I can expect in this result? There's nothing like a minimum error. There's a different approach, and a different approach has a different solution of time value and so on and so forth. Was the main intention to reduce the amount of money spent on each component or function? Soumik, if you want to be successful, you have to have a customer who's willing to pay for your product. So what kind of a customer you're addressing That is the focus. For example, you're building Ferrari cars. Your function is quality, maybe not cost. If I'm building, say, pens, if I'm building, say, low-cost commercial components, cost over a volume may be important for me. Making more parts from a mold may be important for me. Okay, so different products have, if you can see my screen, have a excellence criteria. So when you start out an exercise, you should ask the project, what is the excellence criteria for this particular product? So can we consider DFMA as a Six Sigma operation? It's not considered as Six Sigma. Six Sigma is more of ratios and comparisons. This is actually time and cost quantification. Is this analysis incomplete without considering manufacturing complexity? Yes, we can add up. The more information you add up to your review, Manoj, the more accurate is your prediction. What factor DFA depends? Yeah, DFA depends on an empirical formula, which is driven by a comparison of the Boothroyd's standard 2.93 seconds for assembly time and multiplying that by a minimum part criteria. I'll talk about that empirical formula later. Maybe Yogesh and Balaji can have that empirical formula noted. You can send it as a document in the email reply to the team, to the participants later. Cost depends on material also. This is validated in DFMA. Yes. How much feedback received is close to real values? Okay. Ekansh, it's like this. Garbage in, garbage out. That's what is told about computers. In DFMA, you can have garbage in and gospel out. So you have to get the insight of whether the inputs you're going to the tool is right. The more you give inputs, the more accurate you can make your estimates. The reduction of parts tend to reduce efficiency of performance. Actually, Jatin, it has been proven from hundreds of industrial case studies that a product has lesser number of parts for the same function, has a higher mean time before failure, higher efficiency, higher performance. Bharat Kumar, what is the effective way of building a model? There's nothing like that. There's no effective way. You just keep on building, you keep on making it improve. I can make another 10 improvisations on this DFA model right now. Will it be realistic? It's something you have to check. Will it be manufacturable? Something I have to discuss with my production engineers. But I can keep making different ideas. What I can do with the tool, ladies and gentlemen, is I can get rapid feedback of my design intent. I can build. See, I've done so many different iterations here, as you can see. I can do simple comparisons and then find out which of them is making sense. So I can get this design from a 260 second assembly. Are you able to see my screen? Up to a 49-second assembly. It depends on how much you're going to commit yourself to achieving this. So I'm saving by more than 75-80%. It's about our ability to deploy this tool. I hope that answers your question, Bharat. Abhishek, as far as we are reducing time, the DFA index is increasing. Yes, it is. That's the idea. You can explain the DFX again. Not now, Abhishek. I'll send you the empirical formula. We followed up with some content, and you have the software. The on-context help is a guide. Shoot your questions to us by email. Where is that? Can you elaborate DFMA index? Again, Ananya, I'll send out. You look at the on-context help. I'll pull that out for you. If you don't understand it, you can send a question by email. Where have I lost it? Yeah, there it is. Can you elaborate? Is there a way to test the durability? No, this is not a durability testing device. This is you have an idea for your design. You can validate your design. You can get a feedback of time implication and cost implication. What I showed you so far, ladies and gentlemen, let me tell you, is related to assembly alone. We're going to talk about part in a minute. Okay. Using 3D printing or conventional process. Well, I don't understand your question, Bharat. How can we know the design can withstand conditions? Well, that's an engineering activity. We'll talk about that also in a minute. Can we exactly? There are too many questions. I can't answer this at this rate. What I'm going to do is you can probably note it and send it out to our group, and we'll see how much we can answer. Yeah, wires don't have symmetry. Wires have a problem like flexibility. Praneeth. No, it doesn't do generative design. So, gentlemen, I understand there are a lot of questions. It's nice to see these questions. I'm not sure how to answer them right away, and I'm running low on time. So can I go on to the next part of my? Yes, you can use the software for designing anything, formulas, cars, or anything. We're using this for our own electric tractors that we're doing. Okay, time up. Now, let me take you to the next part of my story, rather, right? Remember, we have this design. I hope some attributes of the DFA tool has come through to you, which is evident from the kind of questions that you're asking. Now, I have this design. Now, I want to show you the next part of this process, which is focusing on making the parts in the design, for which we will use the design for manufacturer concurrent costing tool. What you can do with this tool is you can estimate the part cost and also get very detailed manufacturing review of making that part. So for that, I've taken into consideration this cover. It was something that we just now did as a potential new idea. Can we do that? Thank you so much for that. Now, what we're doing here. Now, before I go on to showing this, I have some normal industry challenges that come up when we do a potential new design for part, ladies and gentlemen. One of them is, what is the best process suitable for making this part? What happens if you change the process? If you're a part of a company, as an engineer or an engineering team, how can you give valid data to your procurement people? This is another challenge that you have. Another challenge for procurement people is, should I make this in India? Should I make it in Pune? Should I make it in Chennai? Should I do it in China or Vietnam? So this kind of overseas manufacturer review of costing from a cost serving perspective, these are some challenges. So anyway, what I'm going to do now is I'm going to show you this one component, and I'll show you the DFM tool, where we can make a quick assessment of the different modules, different possibilities of making this cover. So I have this idea of the IITPR. Can you see it here? And I am taking this cover. Now, if you look at this IITP idea, just for your attention, we are planning to make 5,000 pieces. This was our labor rate. This was our efficiency. If you look at the cover, this is the overall geometry of the cover. Okay, we had one quantity. I can right click in the DFA tool. I can say do DFM analysis, create a new. DFA and DFM are true concurrent costing tools. So the data across one to the other can be interlinked. So I'm taking the data from the DFA and creating a new analysis in DFM for manufacturing this part. So when I do that, this data related to the cover, with the quantity, the name, this geometry details automatically comes into the software. Okay. Again, ladies and gentlemen, in the DFM tool, if you have CAD model, you can import a CAD model. But right now I'm going to do a conceptual. I'll show you CAD models later. Let me maximize the screen. So this is the look and feel of the design for manufacturer concurrent costing 4.0 tool. This is the latest version that we have. Okay. When you give the overall geometry of the part, you select an envelope shape and you select this process material icon. What happens, ladies and gentlemen, is you get this process and material selection chart. So if you select on a process, it'll show you what are the automatically the compatible materials for such a process. Okay, so right now, in the interest of time, I'm going to do. Okay, imagine for a moment, this guy called Syed is a part of a company now. He has got a design from his design team, which has been validated as a good design, which is an improvement of the cover. So 10 parts cover has been made by the design team to a singular part cover. Now they want to find out, can that cover be made in casting? Can that cover be made in casting but in China? Can that cover be made in sheet metal? Can that cover be made in plastics? This is what I'm going to do in the next 5-10 minutes. Can I do that? So let me take this cold chamber die casting process. When I selected aluminium, it is saying, hey, if you're taking a quantity less than 10,000, it is unlikely to be economical. What it means is, you remember our life volume was 5,000. So it is giving me a warning. So if you're actually going to manufacture this, you may have an issue with the costing being more on the higher side. So the DFM tool, what it does is, based on the knowledge that it has as a part of the database, it will give you rapid feedback on your design intent. Let me create a stupid situation for myself. Let us think that this guy Syed has done a good design, but he's taken a very large thickness for this component. Can you see I've typed in the value 12? Hello? Am I only talking to myself? Thank you. Thank you. Okay, imagine, let us say because of some human oversight, some error, this was given as 12. I select this process material selection chart. I select the same cold chamber die casting process. I'll select on this aluminum. Can you see the warning? It is saying, hey, you've selected a section thickness greater than 11.93 mm. It is unlikely to be practical. Okay, so when I make errors like this, I'm just arbitrarily making a 0.25 mm thickness. If you have less than 1.25, it may be unlikely. So imagine if this was a problem that comes at the production stage, gentlemen. Right? So here in the virtual world, even before I went and designed my CAD part, I have a rapid feedback of my design intent. Are you getting it? This is the strength that the DFMA is contributing to the design world by giving them, and without having engineers looking for manufacturing experts, getting a rapid feedback around their design intent. And nevertheless, in the interest of time, I'm going to run this a little fast. That at least I should complete the DFM before the 11 o'clock session. So I know I have a 12 mm problem, but I'm still going to take this value just in the interest of this demonstration. I hope that is okay with you. I know that the problem is my quantity is less than 10,000. I know that the problem is we have 12 mm, but I want to review it today. Tomorrow when I go to office, I will talk to my design head, Dr. Dilip, and I ask him, sir, ये 12 mm करना है कि नहीं करना है? हमारे पास ये machines हैं कि नहीं है? Do we have our vendor who can do this part for me or not? I can do these kind of discussions later, but I have this warning already come up, which I will take a note of, and I'll say, okay. So gentlemen, what you see here, ladies and gentlemen, is the process chart is automatically generated for the casting process for me. And for each element in the casting process, the data generated on the right hand side. This is the IP of the tool. This is proprietary IP of our software, which is automatically generates. So the data comes on the right hand side. And what comes at the bottom is the cost impact of your design intent, which is the material setup process tooling of making this part in aluminum with cold chamber die casting process. This is the breakup. Then what will be the cost of tooling? It is automatically calculated from the entry that we have given, this overview, which has to be perfected. Now it is conceptual. Remember, you have not given accurate data. The software has made estimates. Another important thing I'd like to show you is this data, which is generated in the DFM, ladies and gentlemen, can automatically come into the DFA tool. What is the relevance of this? Imagine if my design team is in the US. Manufacturing team is in, say, Pune, Chennai, China, Vietnam, Malaysia. If they are all residing on the same server, okay, the DFMA suite is installed on the same server, my design team has access to the server, DFM engineers, the vendors, the suppliers, the manufacturing. So while they're doing these review, automatically what review is done by one team can be seen by the other in their relevant windows. So that's how we are also helping the companies to squeeze their design, their product design cycle by over 50% world over. Okay. Now I just did this cover. Let me rename this cover and I'll call it as casting. Now my boss says, since we have a China database, why don't we also do it in China? Now before I go there, let me ask you some questions. I know that you may not know the answers, but just in the sake of showing you how rapid feedback this software generates values in a quantifiable way. Now you see the software is selected as a default and ideal setting. It is recommending that the die casting should be automatic. Now my question to you folks is, what if I change this to manual? Will the cost be higher? Yes or no? And if so, where do you think the cost will be higher? Can you make some guesses? I know you don't know the answers. Can you make a guess? We're going to select this to manual. See, just like, yeah, labor cost higher than manual. Okay. See, you're all giving me feedback based on, yeah, maybe not uniform thickness. Very nice. What's the quantity of parts, right? So you see, there are so many attributes, but when I actually have such a challenge, my question to you is, can you imagine the time the company will be spending on getting this assessment made? If I have a tool like DFM, gentlemen, if I click on this, I click on calculate, watch this. This is my old values. This is my potential new value. Okay. I can do several such attributes. For example, if I change the tolerance from a low tolerance to a very high tolerance, what's the impact? Well, the cost of the mold is going to go high. Where? By how much? I get an exact feedback. So this kind of review I can do with this tool. Now, let me just, in the interest of time, copy this. Let me paste it. Let me rename it. I'll call it as casting dash greaves. This is one of my customers for whom I'm doing a database right now. So I'm going to select the process, same material, same process. What if I select this one, a different location? Can you see my answers on the bottom left-hand corner, ladies and gentlemen? This was my price for the USA database. This is my price for the Greece database that I have. This is localized for a Pune market, specifically for one customer that we're trying to do. So this is the impact. Okay. Now, what I'm trying to show you is, if you do this right, if you set this up upfront correctly, companies can make very rapid design iterations and get a time and cost implication of their design intent, not just from a cost perspective. For example, how much of actual time taken for the process. Okay. For example, let us say if this die casting machine, if I go and select and say change the machine, these are a list of machines that are available in our database. Okay. Before I go further, these are not the only machines that I have in my system. If you look at my library of machines, this is a library of machines that we have as a part of our database. All the standard machines used worldwide is a part of our system. So these are the main headers. Under them, you got subheaders. And some of the most prominent machines in the world are listed as a part of our system. Game milling machines, vertical machining centers. Everything is a part of this database. You have to localize it as you use it for your system. Never mind. Let me come back to the to our DFM component at hand. So let us say now I do a different role play for a minute. Yeah, if I found a vendor in Bangalore location, we change location. Yeah, we can do that. We can do that, Abhishek. Right now, it's not off the box. You can localize it as you deploy this software. So let me come back to this machine, die casting machine in particular. You see, one machine is highlighted in yellow, the rest of the machines are highlighted in green. What it means is, based on the geometry that you gave to the software, it is saying that the clamping force required is suitable. The most economical machine would probably be a 200-ton machine. That's why it is selected that and keyed in here. Now let us see if I was a procurement person in the company. I'm sitting this with my vendor. Vendor says, sir, आपने IIT रूपर के साथ बैठ के 200-ton machine कर दिया, but मेरे पास 200-ton machine है नहीं. I have the smallest machine in my setup is a, let's say, 900-ton machine. Okay, I can do a realistic scenario. This answers a question where somebody asked me earlier, how real can be your results? So this is a realistic, getting my results more realistic to our actual scenario. So I'm selecting the 900-ton machine and I'm saying, okay, what do you think will happen? The process cost is slightly higher for a higher ton machine, right? So because of which it's adding up to the total cost. So if I'm a procurement person, I will say, dekhiye bhaiya, actual ideal cost IIT Rupa has given us for $9 for 9.45 paisa. You're asking me about 50 paisa more because you don't have a machine. Why do you want to burden me? Either you go find a machine or I'll go find a vendor. So this kind of unbiased scientific discussions vendors are able to have with the OEMs because they're having a rapid feedback, mathematical feedback, scientific feedback of their design intent. Getting it? That's one of the strengths that I wanted to show you as we get ahead. So far, I have done 2 iterations of making this component, one casting using a US default database, one using our India customer database. Now let me make another copy and I'll rename this for, say, sheet metal. What if I were to make this component in sheet metal? I'll select this process. You see there are several 11 sheet metal processes that are part of our database. Let me select this turret press. Instead of aluminum, let me take a different material. Again, I'm taking a different database here, and I'm going to say OK. So it's going to switch the data from my previous casting to sheet metal. I say yes. Ladies and gentlemen, do you see the error on my screen? It is saying, boss, Mr. Saeed, you've selected a dimension, a thickness 12 mm, and we don't have in our library a turret press large enough to stamp 12 mm. Gentlemen, imagine for a moment, you did your design, you did your prototype, and let us say at the production stage if this problem comes up, what would happen? Here you see in the virtual world, I've not even designed the CAD model. I just have a conceptual idea for component. I'm able to get a feedback like this. Again, DFMA is not pure science. It's a set of guidelines that have been documented over the last 40 years. So it's not like an ANSYS tool that says, oh, you've not done the machine properly, you can't do a finite element analysis. These are just warning. You can say this is not possible, but you can still say okay, and it'll give you the best estimate based on what it has from the. You see these machines now in turret press, all of them are showing in yellow. What does it mean? None of them are capable of stamping a 12 mm thickness, but nevertheless, it is taking one of the largest machines and giving you an estimate. Okay, so let me just do one more in the interest of time, and I will rename this as plastics. These are all file names. As you can see, in one DFM file, I can have multiple iterations. Okay. And I can have different commodities. When I say commodity, it means a different combination of process and material. That's what a commodity means. So let me take injection mold, and let me take maybe a thermoplastic. ABS is a good engineering plastic. I'll select that. Again, it is showing some warning. It is saying if you have a section thickness greater than 6.3, unlikely to be practical. You have a volume less than 10,000, you have only 5,000, it's unlikely to be economical. Nevertheless, I'm doing an apples to apples comparison here. Let's say okay. So do you see that in about last 10-15 minutes, one given model we had, and we've done 4 different iterations of commodities. Since there are too many numbers here, let me report all of them on a single dashboard. Are you able to see my graph? Okay, so these are at this moment I've done 4 comparisons. So for a given life volume of 5,000, the material setup, process, and tooling for each of these processes. If I go on a process, it is showing you how much. The red color refers to the casting in die with aluminum. It's saying 77% or 11 rupees is the cost of the casting. For the blue process, which is green, it is 4 rupees. There's no tooling for sheet metal. That's why it is almost 0. And the green color is related to plastic. So I can see a breakup like this: material setup, process, tooling, or I can see like a stacked bar graph. So the blue color represents tooling here. I can look at it as a pie graph. If you're a manufacturing expert, you can look at this feature called cost reduction guide. Okay, what this does is if you're a manufacturing expert and you want to tell the design team, hey guys, you'll have done a very complex feature. You've selected a very odd thickness of 12 mm, and that is contributing to the cost of manufacturing this part. This is a tool that manufacturing experts use for having a discussion with their design team. Okay, and moreover, tomorrow, let us say you have become procurement engineers, procurement experts, procurement managers. This is an interesting graph called the cost versus life volume graph. Volume is on the bottom in a logarithmic fashion, 1, 10, 100 in that increments. Cost on the y-axis. Let us say I'm working with somebody, my customer says, sir, boss has said we don't want plastic, we want it in casting. So I will say 5,000 may not make sense. Let me magnify this. Can you see this? I'm magnifying it. Let me bring to the intersection of the blue and the green line. Okay, blue line represents greaves, which is made in Pune, and the green line represents plastics made in ABS. I'm clicking on that. I'll say 5,000 se hoga nahi, sir. If you give me 25,000 pieces, I will match casting of aluminium to the price of plastic. Gentlemen, what I showed you just now in the last 10 seconds, this takes days, if not sometimes weeks, depending on the complexity of the product. Okay, this is what the DFM tool can do. We'll touch on all of the modules as we do hands-on tomorrow. But what I want to do in continuation is I have done an overview of making this new design. And I've given you an overview of making them in different commodity combinations and getting a right estimation of cost. Does this impress you? Okay. So in a nutshell, when you do this approach to your product or projects, gentlemen and ladies, what you can do is you can look at a holistic review of your product. Yes, it is a very powerful tool. That's why it is so expensive, so well defined, and some of the most successful companies in the world. We have seen almost bankrupt going companies deploying DFMA and making successful stories out of their products. I actually sat through one full presentation on a day where such companies have turned around their whole business model because of reviewing their design and making much more elegant and efficient products. Let us talk about our product today. What we have been able to do, ladies and gentlemen, is looked at our product, and this will be a estimate of what we have been able to achieve today in the percentage of parts that we have reduced, because of which the number of vendors we have removed, because of which we have reduced the number of drawings, because of which we have been able to get the reduction in the assembly time on the shop floor. Remember, you had 260 seconds, now you got about say 70 seconds. In the same shift, your operator can assemble 4 times more number of products compared to the previous design. And for the company, if you're a part of a company or this is the overall reduction that you're able to get on the product. So now you may ask a few questions. I want to do this in the next 20 minutes. I still have a portion of my presentation, which I will continue maybe tomorrow. I will hard stop at 11. I know you have another session after this. So guys, when you start out your exercise of doing a product design, please choose your capabilities of which is there within your design community, which I mean, let us say you're going to do a project, which I'm sure Dr. Dheeraj will give you as you group up. So within your team, what can you select as the possibility of looking at your product for simplification? That should be done wisely. Over exaggeration of expectations, usually we've seen not much of success. But there are two again further attributes. If you only look at the part, like I did now, which is part level costing, it is a small medium effort. Matlab, I look at the cover, what if I cast it, what if I do plastic, what if I do sheet metal, small effort, small benefit. Okay, large effort means look at the whole product. You remember the first part of my presentation, 10 parts are there. What are they doing? What is the cover there for? What is the attribute? Can I look at it differently? Can I make it a little more better? This approach takes more efforts, but this approach also has the largest amount of savings. If you look at DFA and DFM, DFA is the cake, DFM is the decoration and the cream and the icing on the cake. Understood? What I mean by that, let me just show you an example of simplifying a product. Soumik, I will tell you that answer. Yogesh, note that question from Soumik on the chat box. I have an example of a hinge assembly here, ladies and gentlemen. Now, if you look at this product and look at the bill of materials, now if I want to analyze, I'm looking at the low hanging fruit, which is the head assembly of this hinge. This is a 1, 2, 3, 4, 5, 6, 7 part assembly. If I sit down and brainstorm, I can probably come out with ideas that can make it a simpler 3-part design or a very ideal 1-part casting design. Normally in the industry, people would go and start making prototypes of their proposed ideas, right? But what I'm saying is, hey, here you've got a tool which can help you to scientifically measure your existing product, your potential new final design of your different ideas, and get a validation of your potential in terms of cost or time reductions. And of course, you're not part of the enterprise, but if you're a part of a company, it is important that you can also figure out what is the benefit you're going to bring for the company. Because only when you project this, based on it, you can ask your company managers to give you time, money, free time from your regular work to concentrate on developing this product. Otherwise, how are you going to even investigate? Isn't that realistic? You understand what I'm saying? So that is why it has become imperative that not just you as a design team, but your procurement team, your upper management team can all involve in saying, hey, this product looks worth investigating, and we have seen upfront validation of the potential. So for that potential, here's the time allocation, here's the money for the prototype, here's the people that you want to engage and work on this project. These are the things that are required to investigate in the DF. So somebody asked me this question, so I'm coming back to, if you look at the innovation happening in the business industry today, why do you have to have a new idea? Why do you want to make a new concept? Why do you want to validate a previous design? Basically, you want to be number one in the business. Maybe you're catching up with in the business. You have a better idea. You have better technology. All of these leads to companies generating new concepts of their potential new ideas, right? Most times, what happens? They'll just go ahead and start generating the 2D models, 3D sketches, finite element analysis, blah 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 blah, till the prototype is ready. And when it is ready for production, that's when the bottlenecks arise. Remember our DFM, when I put 12 mm, they'll say, hello, Mr. Said, how come you spoke 12 mm? You didn't speak to me. How do you think we can cast it? The biggest thickness is 11 mm. So usually there's a break in this understanding. If you have a early manufacturing analysis tool like DFMA, you can move this peak periods of problem resolution from early stage of production to early stage of product design. Now, some people may say, sir, there's already a company, they already have a lot of CAD models, they already have doing work, they're already making money, they're profitable. Yes, most of our customers are using DFMA when they have good amount of engineered CAD data and using DFMA at this region to see, hey, where there are pockets of improvement. For example, that bushing. We don't have, what if the bushing is not there? Why make it out of aluminum? Why not make it out of nylon? Why should the cover be two parts? Why not we make it a single die cast part? Why don't we make it as a singular injection molded part? That's how design DFMA is helping companies improve their launch time by over 50%. So, gentlemen, what I do is I have a lot of case studies, but let me just see. Let me end the show here. I have a lot of case studies, as you can see here, but I did visualize this. But what I'm going to do is I'll leave the forum open for questions, which you can even note and not only put it on the chat box, but send it out to the email that was shared with you, so we can answer them. And if there are any questions specifically on the two modules that I started to show the demo, I would like to take this next 15 minutes or 12 minutes that we have to answer those questions. We'll come back to these case studies tomorrow. Is that a good deal? Hello? And if anybody wants to voice out or ask questions, I'm not sure, you can post it in the chat box. I'll be glad to answer here. Aryan, there is no such average reductions. We have seen fantastic results where the score is in 400, 500, 600% more than what the existing design is. I'll show you some examples tomorrow. Handling requirements and difficulty affect efficiency. Can we increase it? So, yes, you can. If you make the handling simpler, means the operator takes lesser time, and if this takes lesser time, it will automatically get into the empirical impact that the DFA index will go up. A DFA followed by CAD or CAD followed by DFA. If you already have CAD, you can do DFMA. Otherwise, you can do DFMA first before you start engineering CAD. Can we get the manuals and models? Yes, you're getting a manuals, Akshay. You already sent it. Unable to download the file, that's an IT problem. They'll solve it for you. Abhishek, reach out to Balaji and Yogesh. Both the manufacturer and buyer use DFMA and get their predicted cost can change. Yes, today most of the companies engage with their vendors so that both of them win. Okay, so they engage DFMA both ways. It doesn't, the improvements are done by that suggestions for redesign. It does not recommend what to do. It will tell you what's the impact of your design intent. Gentlemen, please don't post about unable to install the software. That is a thing that you can write to your folks on the email. They will reply back to you. Please use this chat box to answer questions related to the presentation, because your chat box is running so fast. I'm trying to answer as many questions for everybody. Okay, related to the software installation, you don't need to use the software today. I'm going to give you a license valid till the end of this week or maybe later. Overheads taken into consideration. Very nice question, Sai Dikshata. Our software does take estimation of overheads. There's actually depreciation estimation that the software also does. So if I go to on context help, are you able to see my screen? Please, guys, don't ask any questions now. Just hang on. I don't want to miss out everybody's questions. If I go to on context screen and if I look for depreciation, you'll find estimations of this under this title. You can look for that. You'll get this information related to that. The point of making a unit body out of many parts increase. Although you need to simplify that question, I didn't get it. Difficult to increase the production cost. Possibly making a unibody out of many parts. Yeah, you can make a unified body, and you can see what the impact is. Sometimes, Alok, a combined multifunctional part could be cheaper. Sometimes we've seen it being different. Here's the rule, ladies and gentlemen. Can I tell you a rule? Hello. And after I say it, you can probably type it out. There are two rules for doing a DFMA costing. One, there is no true cost estimation tool in the world. All of this that I'm showing you, these methods are all documented over the last 40 years. These are guidelines. Okay, so there is no true cost estimation tool in the world. That's rule number one. And the rule number two is, in case of doubt, you refer to rule number one. Okay. Any other questions that are there? Design complexity will affect if you use single complex part, but cost decreases. So it will be a trade-off. Yes, you're right, Sai Praveen. If you take very commodities like printers, consumer products, they do make complex part, washing machine, microwaves. The idea is the cost of the initial component will be lesser, and the trade-off is a decision which a company would make. For example, today printers are cheaper, right? But the printer ink is expensive. It's a designed business decision. So if you're a part of a company like that, you'll be given that excellence criteria which you may want to follow. Limitations. Ramya, explore the software and you come back to me with limitations. Okay. How many number of products to be manufactured affect the design? I didn't get that. What's that, Ikansh? I didn't get your question. No, 3D manufacturing is not there, Jashan. You can build customized user processes. If you're seeing my screen, you can build. Sorry, where's that? You can build user processes. If you're seeing here, user processes, customer user data, you can build 3D data. We have done this for FRP for some aerospace companies. They own the design, they own the proprietary database. So you can use this tool as a platform to build this data. You can build customized data for 3D manufacturing. You can do customized data for different equipment. It's possible. Can DFMA be able to suggest manufacturing? It will not. DFMA will not suggest a manufacturing process. You select a process, it will tell you the outcome like this. Okay. If you remember, Ashirbad Sahu, if the software becomes so intelligent that it can suggest the process, available vendors, trust me, when you finish your education and come out of the college, you won't have jobs. As a matter of fact, I also don't have a job because the CEO of the company will be able to run all of this automatically. Thankfully, today that doesn't happen. Okay. Does it use? No, it doesn't use machine. Yeah, machine cutting algorithms are used. Good question. I'll take a minute to answer this. Let us say if I have to do a machine tool setup, I didn't do this as a part of this. Please watch my screen. I'm just adding this in the interest of time. In the interest of this question, please look at my screen. Let us say I added a machine. All of this machine is coming from my library. I already show you that. I have 3 types of libraries. We'll talk about this tomorrow. Machines, materials, and library operations. Okay. Now machines I showed you earlier. If you see materials, okay, so these are materials. If you select materials, there are subcategory under materials. For each subcategory, it will tell you what are the processes it is suitable for. And for each process, ladies and gentlemen, the variables are calculated and kept in the database. elaborate actually. So you don't actually look at all of this, but if you're interested, you can go and review this. Remember, we were getting this practical limits warning that all come from this library integration. Like that, you can go and build your own, insert your own category of a new material. Okay, sorry, whatever. Rupa, and add your own new materials. And you can select what process it is suitable for. And for each process that you do, you can go and key in the values. Okay, you can do this. Anyway, I'm not going to look at this now. Similarly, you have even for operations. Let me come back to that in a minute. Let us say I have this machine. So the machine, its operating rate, its machine power, the spindle speed, all that is automatically brought in from the database. Are you seeing this? Let us say I go to add one operation. I'll add a single operation. I have 6 minutes, so I'll just take a simple operation of drilling a hole. Look at this. Are you able to see my screen, gentlemen? It says drill a single hole. What it wants the information from the user is length of the hole and diameter of the hole. Let us say I say length of the hole is 15, then the thickness of the material was 12 mm, so I'll say 12. So I give these two variables. If I calculate, you see, it is giving me the cost for drilling a single hole. It is telling me how much is the material removed. It is telling me what is the time spent for the operation. It is telling me how much is the spindle speed required. All of this can come from the software. Now, let me come back to the ML algorithm suggestion. Now, if you see these variables, you see 1, 2, 3, 4, 5, which are editable. 6, 7, 8, 9. These 4 are not editable. This is editable, and about 11 variables are shown here. Can you see that? Yes or no? Thank you, Saurabh. Looks like I'm the only one seeing. Nobody else is seeing, I guess. Just hang on, Ashirbat, hang on. Let me go to the library of operations. I have 5 minutes, and I'm very conscious of my time with you guys. I know you'll need a break after this. If I open this library, okay, this is the library of operations, ladies and gentlemen. All of the processes that are used worldwide is a part of our database. 40 years of research work. Let me take a
Mr. Syed,
Yes.
hello. Sorry for disturbing in between. So I just want to tell that in case you need some more time, like 10-15 minutes, it's okay with me.
Oh, thank you so much.
Yeah.
I'm very time conscious guy. So okay, I appreciate it. If 10 minutes is okay with all the participants here, you can say yes. I will not take more than 10 minutes beyond this session.
Yeah. Take 15 minutes. It's okay because I can handle them later also, like from 1:30 to 2. In case you want to go further, then it's okay.
No, I do have a session at 11:30 with my other team. I will
Sure.
talk about that team and leave you with that interest also.
Sure.
It is connected to agriculture, so I'll talk about it. Yeah.
Yeah. Okay.
So what I was showing you here is my library of operations. In that, I picked up the single drill hole, which I just now added. If I edit the formula for single drill hole, watch this. Ladies and gentlemen, what you're seeing here is the calculation tab of machine cutting algorithms that are running in the background. What I'm scrolling down is the equations that drive a single drill hole. Okay, how awesome is that? And if I go up here, we see the variables 1, 2, 3, 4 on the left hand side. Keep watching, keep watching, keep watching. I've got 53 variables that drive a single drill hole. Now let me go back to this variable tab. But you see here, if I look at the headers, all the variables are not shown to the user all the time. Only some are shown always. Most of them are never shown. If you see this there, if you look at the conditions, which is marked, can be edited by the user. Others are not edited by the user. The values, the calculations, and the metric system and the English system is all estimated here. So if you run on this calculation and see, okay, and you get a value, and when you put this in, you can run. You can actually edit your calculator tab like this. And when I put these numbers, I get an estimation which is validated here, and I get these values. So that's why some of them are editable, which are marked as tick box, are editable, which are not editable. You're getting the picture? What I'm trying to show you is, yes, these are each of these different calculations, ladies and gentlemen, is elaborately documented for the different operations, each of them having their own specific editable formula, standardized, perfected over the last 40 years. So that you and I, like users, don't have to worry about the background running machining method things. I can only focus on my design, which is I want to know how much it will cost in terms of time, in terms of cycle time, in terms of spindle speed, in terms of overall cost to do my activity and go on from there. I hope that answers your question. Okay, so yeah, thank you. I was actually going to do this tomorrow, but since you asked the question, yeah, power consumption, all the details is right here on the system. This is a CNC machine. This is highlighted here. Yeah. So, gents, in the interest of closing down and telling us who we are, there are this attributes of these case studies I'll show you tomorrow. I want to just end up by telling you a little about us. There are two things that we do. Actually, three things right now. One is we do this as a part of our exercise. We build customized as a part of our company DSPAD. We do customized lithium-ion battery build. So if any of your projects have like EV racing, if you're doing an electric aircrafts, if you're doing drones, if you're doing underwater marines, if you're doing submersibles, you're doing military grade products, if you're doing like medical devices, please feel free to talk to us. We'll be happy to help you with being a part of the project. When I say help, we are an MSME company. We can probably be the battery partners. We've been doing this for the last 20 plus years again. And of course, you already saw our introduction today about DFMA. What we're doing to the industry is we help do the companies with their product design review and actually helping them to build a better product. There'll be enough for assessment. Will we be provided? Yeah, we've already been provided material, Abhishek. Not only is enough for assessment, you can get more if you want, but if you want enough for assessment, that has also been facilitated. So you can look at it, Abhishek. So other thing, ladies and gentlemen, I've been doing with my equally crazy set of partners, who's as young as me, is I'm building an electric tractor, which is one of its kind in the country. It's my company startup in 2019 end called Celestial Mobility. If you go to YouTube and look for Celestial Mobility, you'll probably find videos about us. We actually launched this product on 11th March, and 5 days later it was locked down. But we have been doing good amount of testing and things since then. And I'm not sure if you can see this, but I'm going to play. Is of the rotavator, not of our electric tractor. So I understand that this is a division related to agri and water innovation in agri and water. So if this is of interest to you, we'll have to talk about it some other time. And of course, we already shared the email links for you guys to have a look at it. So feel free to write to us at support@techsupport.com. I'll leave the question open for the next 5-7 minutes so that we will close by 11:15 if you like, 11:10 maybe, because I have a session at 11:30. I need to take a break before I get into that. So yeah, I'll leave a session open for questions on the chat box. If there are no questions, shall we call it a day? I know you'll have had 2 hours with me. No questions, very nice. Total initial tooling investment include the mold cost, Himanshu, mold cost, any consultancy cost, special tools. Thank you all. You all have been a very patient audience. There were secret messages. I hope you all have got it. Let us see if we can capture some more in the next 2 days. Thank you. Thank you very much, everybody. This is the emails again. I'm not able to make out your voice, sir.
Today, it is again a bit of unfortunate, but it's still good that all of you are safe.
Dr. Pushpinder, your sound is really low.
So first of all, I really would like to thank you for the efforts that you put in the placement cell of the department. Now, on this, I want to tell you that you have been probably the first people from the department who tried to really something more recently.
Dr. Pushpinder, I may again disturb you. Dr. Pushpinder, you are not audible. Like, at least to me, you are not audible.
No, he's not audible, yes, even to us. Pushpandari, I agree. I think I heard you say that I'm the first session and you're thanking me. I would like to say thanks to your team first, Dheeraj sir especially. And I would like to tell you why I and my team have been very thankful to you all guys in giving us this opportunity. I hope you understand that we have a very selfish mission at DSPAT, and our mission statement is out there for you to see. We want to see India go up on the World Innovation Index. And the one way we think we can do is by bringing this awareness of such a tool in the hands of our design community. When I say design community, academic as well as industry, so that they have an unbiased way of getting their feedback, and that will help them to build better products for themselves, for their companies, for their institutions, and most likely get India on a larger scale on the map of the world, where we build quality products. So, Pushpandarji, thank you once again. If your system is now good to think, we'd like to hear you, please.
Because,
Sir, I would like to thank you Mr. Syed for such a detailed lecture on design for assembly software on behalf of our organization. It was extremely informative class for our interns. Thank you very much, sir, for your valuable time and sharing your experience in the area. Thank you.
You're welcome, madam.
Yeah, thank you, Mr. Syed. I also want to add that in case you want to have some questionnaire to be passed to the students, like we would be happy to do that to get a feedback in case they want something else also. Maybe.
So Dheeraj, what we can do is they have their email. I mean, we have flashed the email addresses for them to shoot questions. We'll be happy to answer them through the course of today and tomorrow. The questionnaire is going to be a flash questionnaire. We would want to control it and send it out on the third day towards the end of our session. And that questionnaire will be a time-based. Of course, we are going to give you about sufficient time and buffer for you to look at it and answer, even with technology issues. You'll be able to answer it within that time frame. You can still answer it beyond the time frame, but whatever comes, those are the metrics for which we will pass on to you, Dheeraj sir, of the people who have answered and what time and so on and so forth. So we have a good insight of whether our training and content has gone on well to the participant community.
Yeah.
Some people are asking for the material, sir. We have sent an email yesterday. Balaji has sent. I hope we can send it out to them, which will help them in the hands-on session from tomorrow.
Yeah, sure. Okay. Fine. I'll do that. Yeah. So all the installation issues, I think I'll be able to settle a little later. I have a session with Mr. Balaji at around 12 to know why this thing is not working. So we'll get back to students. Okay.
Sure, no problem.
Yeah.
Don't worry if the software doesn't work. We will still help you with each of you getting the installation, and we'll extend the time for the license to work beyond that. So that is a promise that we will keep.
Okay. Thanks a lot, Mr. Syed.
Thank you, sir. Good day.
Fine.
Bye-bye.
Bye. Yeah.
Bye, everybody. Take care.
Yeah. So, so hello, everyone. Welcome to the online internship carnival. So actually, I really want to take a break because I think it has been really 2 hours for you guys. So let's assemble at 11:15 again. So everybody will keep quiet for 5 minutes and then we'll start at 11:15 just for a break. Okay. I hope it's okay with all of you, or yeah, fine. It's